Alright, for our last problem on combinations, I have it listed as a medium difficulty, but it's really pretty tough. I only have it listed medium because the next one's even harder. Here, what makes it so tough is that it requires you to understand the difference between the three concepts that we've gone over: permutations, distinguishable permutations, and combinations. So permutations are when we have rank order from first to last with regard for who comes in first and who comes in second. Distinguishable permutations is when we have a class of objects within that longer list and we don't really care whether they're flip-flopped. So AB is equal to BA. Those are distinguishable permutations, and they are always less than permutations. Combinations is the choose function, basically. It's when I don't care how many elements I choose out of a list, just so long as I'm choosing them out of that set. So, with that in mind, let's look at the problem. How many ways can a full house be dealt in a 5-card hand of poker? Well, first of all, a full house, for those who don't know the rules of poker, is 3 of one card and 2 of another card. Now, for my purposes, I'm going to write the highest possible full house, which is ace, 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 king, king. Now you're probably thinking, there are lots of other full houses, even ace, ace, king, king, king. And you're absolutely right. But before we can calculate that number, and that number is important to us, we have to first determine how many ways can we get this specific type of full house. Once we have that number, we multiply it by the total number of types of full house that we can get, and we'll get the total that's required. So, the first question we have to ask is, how many ways are there for us to get 3 aces? Well, there are 4 aces in the deck, and we're choosing 3 of them indiscriminately. So that's 4 choose 3, which is equal to 4. You don't really need factorials or your calculator to do that one. Now the question is, how many kings do we need? For a similar line of reasoning, there are 4 kings in the deck. We need 2 of them, so there are 4 choose 2 ways for us to do that. Now here you might need to break out your calculator or do a little mental arithmetic, but it comes out to be 6. There are 6 ways that we can choose 2 kings out of our 4 kings in the deck. So that gives us 4 times 6, or 24 ways to get this specific type of full house. Now, the bigger question is, how many types of full house are there? Well, you might be tempted to think distinguishable permutations are appropriate here because we've got classes of an object, but order matters. So there are 13 different types of cards, from 2 all the way up to ace. And you might be thinking, well, I'll just do distinguishable permutations on 13 and 2, or 13 and 3 and 13 and 2, and that will get me the answer. But it won't, because order matters. Ace, 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 king, king is different than ace, ace, king, king, king. Here, AB is not the same as BA. So we need to use the original permutation function that we developed. Now again, I said there were 13 types of objects in a deck of cards, and we are picking 2 of them, namely whatever is going to be our first choice and our second choice. And again, order matters. And this is, for those who can't recall, 13 factorial over 13 minus 2, which is 11 factorial, which comes out to be 156. So what's the significance of 156? Once again, that's the number of ways that I could choose 3 of one type and 2 of another from a set of 13. Okay? One of the fundamental principles of combinations and permutations is that when we want to know the total number, we have to multiply all of these things together. So 4 times 6 times 156 will give us our answer of 3744. In short, there are 3,744 ways for us to get a full house in 5 cards of poker.